Guys, what's up? It's Oscar with DIY Technology. Not long ago, I received a request to build a nice looking portable speaker system with long battery life. So I thought it's a good idea to take my mind off from other projects and build a mind-blowing speaker system. And hence, this is the result. Hope you guys like it. In this video, I'm going to show you the step-by-step process I had to go through to build this system. So without wasting any more time, let's begin. I started with organizing the parts necessary for the internals of the system, such as these good quality 14 watts speakers I harnessed from a broken LG LCD TV, an MP3 decoder module with built-in Bluetooth 4.0 receiver, a 3-cell 30 watt-hour lithium polymer battery, balanced charging board for 3-cell LiPo battery with 15 volt DC input, a 15 volt DC power supply for charging the battery, a 30 watts stereo power amplifier board, audio spectrum analyzers, charge indicators for 3-cell LiPo battery, aluminum power switch, some aluminum standoffs, DC to DC isolation module for eliminating interference in the MP3 decoder, and finally some red color LED strips for side lights. After I'm done organizing the internals, I arranged the parts roughly as shown to figure out the dimension of the carbon fiber casing I need to design. Next, I designed the casing using AutoCAD and process it further for cutting. Keep in mind that the thickness of the panel is 1 millimeter. After a long and anxious wait, my panels finally arrive. Now I can proceed further to assembly. I begin with fixing the aluminum standoffs. I make sure that the screws are tight, as these standoffs are going to be like the foundation of the whole casing. Next, I install the charging board. I had to make sure that the power input port was in absolute level with the hole on the rear panel where the power connector would be connected. So it took me more time than I expected to install the charging board. Now I'm fixing the power and charging status indicators to the rear panel. The green LED will indicate the status of DC power input. That means when 15 volt will be supplied to the system, the green LED will stay lit, and when it is disconnected, the green LED will simply turn off. As for the red LED, it will only light up when the board is charging the battery. Once the battery is fully charged, the board detects this and stops supplying charge to the battery, hence turning off the red LED, which indicates that charging process is complete. Now I temporarily fix the side panels and put the top cover on to see if everything fits properly. At this moment, I am temporarily putting in the speakers just to see if my calculations and dimensions are correct. Now I am preparing the side LED lightings. For better strength and reliability, it's better to apply a good quality glue to all the corners and edges from the inside. Now I am installing the side lights using a good quality soft double-sided tape and hot silicone glue for extra hold. Time to put in the speakers, also using a good quality double-sided soft tape for anti-vibration and glue for additional hold. The speaker is further fixed with a screw underneath. The same method applies for the second speaker. Next, I carefully mounted the amplifier board on top of the right side speaker using double-sided soft tape and glue. I am now fixing the audio output or the headphones jack using glue and hot silicone gun. For added security to hold the amplifier board in place, I apply a good amount of hot silicone glue to the sides of the board. Now I solder the cables coming from the LED indicators to the charging board. Time to test how the charging board is working. First, I connect the battery to the balanced charging port and then connect the 15-volt DC power supply to the power input port. Well, everything is looking good. After a little inspection, time to proceed further to install the LiPo battery. I make sure to use a good quality double-sided soft tape along with good quality glue for extra hold. As you can see, the speaker system has begun to take shape. I add some extra hot silicone glue on the battery and the left speaker to hold the battery securely in place. It's looking good. I now start working on the top panel where I'll fit the power on off switch, the MP3 decoder module and the charge level indicator. It took me a nice amount of time to fit the MP3 module on the top panel. I am now making the DC to DC power isolation board. This isolation board's sole purpose is to supply clean power to the MP3 decoder module. The reason this has to be done is because the MP3 decoder module cannot be powered in parallel with other modules inside. If the MP3 module is powered in parallel, the controller on the module generates sounds like those tones in fax machine, so this can be really irritating. Now I'm connecting it with the internal cables. This process is going to take a while, so let me take some time to request all of you to please subscribe to my channel and please like my video. This way I can remain motivated to build more exciting and cool looking DIY systems. If I manage to get more than 2000 likes on this video, I am going to build a carbon fiber gaming PC. It will have a super cool design. So guys, one click is all it takes to keep me motivated to produce more videos in the future. Let's get back to our speaker system. It's time to fit the power isolation board inside the casing. After a little bit of inspection, I apply power to test the isolation board and output from the board. As you can see, it is giving an output of 5 volts, which is the voltage required for the MP3 decoder module to operate. Here I am fitting the audio LED level meters above the speakers. It's time for me to spend good amount of time for cable management. This can be a very hectic process which requires patience and cool mind. Guys, again I would request all of you to please subscribe to my channel and please like my video. Help me remain motivated to make more cool DIY videos. I have a real crazy design in my head to build a super cool carbon fiber gaming PC. So as I mentioned earlier, if I get over 2000 likes for this video, I promise to build that carbon fiber gaming PC. Now I am fitting the LED battery charge level indicator. I soldered the cables that will be later connected to the charge level indicator before closing the top lid. We are almost done here. Now I am soldering the cables to the on-off switch. Well, the top lid is ready. Time to do a little test run. Now I am pasting the feet. I am using nicely cut pieces from soft mouse pad, which is effective for anti-vibration. And to securely fix it, I am using a double-sided tape in the middle and glue along the edges. The results are very impressive. After sticking the feet, I keep the speaker system on a leveled horizontal surface for several hours so that the feet can nicely bond with the base. Time for the final internal inspection of the system. Mainly, I try to see if all the cables are secured and connected properly. Also, I try to be sure that no cables are shorting anywhere inside the system. Now it's time to close the top cover, but before that I have to make all the necessary connections between the parts on the top lid and inside the case, such as the on-off switch, charge level indicator, power to the MP3 decoder module, and the audio output line from the MP3 decoder module. I further apply glue on the connectors so that they don't get loose from vibration in the future. I carefully position the cables inside and close the top lid. Finally, I remove the screen protection and time to test. Here I am showing you how the charge level indicator and charging system works. Okay guys, it was really nice to build this speaker system. I hope you guys liked it. Please don't forget to like this video and subscribe to my channel for more amazing projects. Stay tuned for my next video in which I'm going to do a detailed review of this speaker system. Now I need to go out and enjoy my speaker system for the time being. Bye.